So in the inductive step of the proof, we assume that for a particular positive integer k, this equality involving the parameter k is true, and we'll call this assertion P of k. And we'll use this fact to show that the same equality with the value of k plus 1 is true, and we'll call this assertion P of k plus 1. The equality using the value of k, which we are assuming to be true, is called the inductive hypothesis. Now the way we show that P of k plus 1 is true is we start with the left-hand side of the equality we'd like to show. We show that expression is equal to something else, which is in turn equal to another expression. And then after a sequence of these steps, we end up with the right-hand side of the equality we'd like to prove. Now if all these equalities are true, then it in fact holds that the left-hand side is equal to the right-hand side, and P of k plus 1 is true. Now here are the steps of the proof filled in. The first step is to separate out the last term in the summation. So the summation now goes from 1 to k, and this last term, where j is equal to k plus 1, is now sitting outside the summation. Now the next step is important because this is where the inductive hypothesis is applied. Notice now that the summation term in the expression is equal to the left-hand side of the inductive hypothesis. Since we're assuming that the inductive hypothesis is true, we're assuming that the left-hand side is equal to the right-hand side. So we can replace the left-hand side of the inductive hypothesis with the right-hand side, and the resulting expression has equal value. Now the remaining steps are just algebra. We take the k plus 1 term, multiply, and divide by 2. And in the next step, we consolidate the fraction. Now we notice that the two terms in the numerator both have a multiple of k plus 1. So we can factor these out. We get k plus 2 times k plus 1. Now, in the next step, we just swap the order of the factors in the numerator, and we get k plus 1 times k plus 2 over 2, which is exactly equal to the right-hand side of the equality we wanted to prove.